Welcome back to the Hardware Unbox podcast. Episode 5 is right hitting your ears right now. This is a news episode, so we talk about quite a lot of different topics. Xbox console leaks, the Microsoft-related stuff, looking at Zen 6, RDNA 5, they're sort of targeting. So we have a big discussion about that. We talk about whether upscaling and those sorts of technologies are sort of killing games and optimization and how that might affect sort of upcoming consoles if they're heading more down that path. We look as well into the Asus ROG Matrix 4090 that Steve talked about, Threadripper leaks and rumors, DLSS 3.5 Ray Reconstruction recap, and a little bit of monitor news from a brand that has been doing things on the dodgy, it sounds like. So we talk about that as well. So yeah, as I said, news episode, let's get right into it. So Steve, how you doing? We've got a news episode coming up, but it sounds like you also have got some health updates. We were talking a bit earlier.
Yes,
feeling better?
I am
100%?
feeling 95. I'm going to go with.
Okay. Good.
The throat's still and my voice still isn't 100% there, but it's much closer than it was last time we had a discussion. And yeah, energy levels are up a bit more, so we're on the mend. It's only been 3 weeks or something. It's a bit crazy.
3 weeks, nice, all coming together to talk about news and things that we've been testing, and that's it. So
all of the news and things we've been testing. So this should run for about 20 minutes.
Yeah, we've got a long episode. No, which should be all right. There's actually quite a few things that have come up this week, I think, that are sort of interesting. Why not just get into it? Because I think probably the biggest news of this week that's sort of gaming hardware related has been this massive Microsoft/Xbox console leak, which I think for a lot of people is probably not that exciting if you're a PC gamer, because as we all know, we're not going to be using an Xbox Series X anytime soon when we've got our powerful PCs on hand. But yeah, so this is not a rumor, which I think is probably the most interesting aspect to it. We've got some documents here that were leaked from the FTC versus Microsoft case over in the US. It seems that Microsoft inadvertently attached some documents, the things that were supposed to be confidential and redacted, and made them public by accident. So we've got all this information about their console strategy. And I think to kick it off, there's some interesting things about what Microsoft are targeting for the next generation consoles, and specifically around the CPU, GPU designs and things I think would be interesting for people to chat about. I guess one of the main slides that we've got from this leak was this discussion of the hardware decisions that they're making, the sort of things that they're targeting. So Microsoft are planning a next generation console for 2028, which I guess is 5 years from now. This document, I believe, was from 2022. So they're sort of looking 6 years into the future. And there's a couple of things they've listed here. Things like CPU ARM64 versus X64 with Zen 6 as the sort of flag there for the X64 design. Balance of big and little CPU cores they're thinking about. And GPU, they're deciding between a co-design with AMD or licensing AMD's IP, and they've got Navi 5 listed there. So that would be obviously 2 generations into the future. It's interesting. I think none of that stuff would be unexpected. I would think that consoles that have been made with AMD processors and GPUs for the last couple of generations, they're probably going to be considering that hardware again. What I'm interested, though, is that I guess firstly on the CPU side of things, they've listed here Zen 6. Now, I would have thought that Zen 6 would be ready before 2028.
That'd make sense though, right? Because if they're releasing the consoles now, would they go with Zen 4? Because that'd be too expensive, right? I would have, again, not a console expert, really don't follow the console industry that closely, but I would have thought they would jump on an outgoing almost platform where, the CPUs are discounted, it's maybe an older process, that it's not as expensive to manufacture, because what's the price point for these things? They're usually it's significantly cheaper than a computer.
Yeah, I would have said $500 US, but then inflation, who knows where that's going to end up. I think you've probably got a fair point there, because with the Xbox Series X, so the current generation of consoles, they launched with Zen 2 inside, and the same year we got Zen 3 processors. So this is like your Ryzen 5000 parts. Those were released in October of 2020. And the Xbox Series X was released in November. So, the new CPU generation came a little bit earlier. So, I think that would probably make sense. I was sort of thinking, we're probably going to be getting Zen 5, we'd be hoping next year, sort of making that 2 years since the launch of Zen 4, which would then mean Zen 6, hopefully a fair bit before 2028. Otherwise, we won't have a lot of things to be covering in the CPU space. But yeah, you'd be expecting that probably desktop PC CPUs would be on Zen 7 by then, and then we'd be getting Zen 6 for this next generation console.
I would say, people might have this the wrong way, I'd say by the time they're released, in terms of like technical hardware specifications, they're generally outdated by at least a generation because they're meant to be cost effective. But the way they utilize the hardware can be much more optimal, so they don't look as poor as they would if they were a PC running Windows playing the same games, for example.
Yeah, and I think the CPU is really key as well, because that sets the baseline for not just those consoles, but also the PC games and game engines that are released around that time. So yeah, even though the CPU could be a year or a generation out of date, that's still going to inform the sort of level of performance that we're getting across a whole range of different things, and would be, I would imagine, Zen 6 versus Zen 2, a fairly substantial performance increase. Zen 2 today is aging quite rapidly, I would say, in modern games. You're getting a big uplift from things like Zen 4 3D V cache.
Yeah, 70% I would have thought on average across 20 games or something like that. And that's just, we're talking about Zen 2 to Zen 3 3D V cache, not Zen 4.
Then again, we might see clock speed increases as well, because these consoles are not super highly clocked. The Series X, I believe, is like in the 3 to 4 gigahertz range, something around 3.8 gigahertz-ish, which is certainly not the premium clock speeds that we're seeing from current generation parts. The one thing, though, that's very interesting here was Microsoft sort of tossing up between, do we continue down the AMD path with x64-based CPUs, or do we go with something ARM-based?
Okay.
Another slide suggesting that they've probably already made that decision. There's this sort of timeline slide that talks about making that ARM64 decision around now, so obviously about 5 years ahead of time, so they can get the design going for these parts and make sure everything's locked in. I would have thought that going with an ARM64 chip would be a mistake. They've already built the last two consoles on...
Yes, I was thinking compatibility, right?
Yeah, they'd have to do sort of like an emulation layer if they wanted to get all the existing games running on an ARM-based processor. And again, I guess there was this whole thinking a little while ago that, oh, maybe x86 has sort of reached the limit and is dead and there's not much going on. But I think that's been pretty easily disproven at this point, that there's still a lot of life in that platform, and going for an ARM CPU wouldn't really be of any advantage, I wouldn't have thought.
Hard to say without seeing it, but yeah, probably not. I think there'd be more disadvantages than advantages to that approach, and yeah, compatibility obviously being a big one. And then if you have to do like an emulation layer, that would be very performance taxing. I don't know if that would be feasible.
Yeah, I would have thought these days that, we've kind of gone past this whole era of like throw out all your old games and console, and it's all restricted to that one specific console generation, like the games. Like, that's not really the way people want to be buying and playing games these days. Like, you want to be buying games that you can play for as long as possible. So supporting that across multiple generations, which has been the sort of whole PC thing, right? Like, you buy games on PC, you can play them effectively forever. Now, of course, there are some issues with older games supporting things and whatnot, but generally speaking, you can quite easily play older titles, whereas consoles in the past, you haven't had that opportunity. But then this whole moving to a similar architecture to PC is hopefully going to allow consoles to do that. So going backwards on that would be very disappointing, I think, for console owners.
Yeah, it'd be a massive downgrade, and yeah, it'd make the PC platform look a lot more attractive and more cost effective over time.
Yeah, especially if they keep going with like digital games, like the whole push of getting rid of the physical games, moving more towards digital games, then there's going to be, people are starting to build their libraries digitally on console for the first time. Of course, PC games, we've sort of been doing that for a while with Steam, but the whole benefit of, you build your digital library is that as you upgrade your PC and games and things like that, you can still play all those games. Like, it's still all fine. You can still run them. So yeah, getting rid of that wouldn't be great. But then again, like, Apple has kind of shown that you can do emulation to some level of success with their sort of shift towards ARM based CPUs. So again, I guess it could be possible, but I think that they will stick with x86. I think that's ultimately the decision that they will make.
That would be my guess as well, yeah.
We'll talk a little bit about the GPU as well, because the interesting thing I found here is whenever you think about a console generation, there's always that thinking of, will they continue to use AMD, or will they even consider alternate platforms like Nvidia specifically. I guess maybe Intel, because now they've got their sort of GPU division going. But in this document is very clearly listed GPU co-design with AMD or license AMD IP. So it sounds like Microsoft are not even considering switching to an Nvidia GPU for this sort of design. I'm guessing that you think that's pretty much expected.
Yeah, I'm not sure it's the consideration for them to make. I don't think Nvidia would be interested. Again, this is just pure speculation on my behalf. I don't have all the facts and figures, but I don't think the margins are probably big enough there for Nvidia to be interested in supplying consoles.
Yeah, possibly. I mean, they've designed I don't know how much of the design they've done, but they do supply the GPU for the Nintendo Switch.
Mm-hmm.
So again, that's a fairly low tier SoC. So I guess, if we look at a Switch price, it's fairly similar to like a PS5 price while being a lot slower.
Mm-hmm.
So potentially there are bigger margins on that sort of more mobile design product. So you make a smaller SoC, it's cheaper to manufacture, and maybe that's what Nvidia is trying to target. And yeah, I'd probably agree with you that they're probably not interested in making like a 400 square millimeter sort of monolithic CPU plus GPU big console design, because the margins on these products are not great.
That's my understanding.
And we've seen Nvidia move to this whole like AI focus. Let's sell our silicon for make thousands of dollars of profit per chip.
Mm-hmm.
Whereas with the console, it's like, how much would they be making? Like $10, $20 maybe?
Yeah, dollars, not thousands of dollars. Yeah, so.
Yeah, that's probably a consideration. I think that there's probably some fanboys that would be disappointed that Microsoft's not considering alternate technologies and alternate plans. But realistically, at this point, I think AMD is the only company that's got, not the only company that can provide technology, but the only company that's got the proven sort of background of producing these sorts of parts. Even if they did want to go with like an Intel, for example, it's very new.
Mm-hmm.
Like they have to start planning off this whole GPU ecosystem that's, it's only been around for a little bit. They really need that reliability and longevity. And I guess they've proven, AMD, that they can produce these sorts of chips. Whether or not they go with the co-design or licensing of the AMD IP, I guess it doesn't really make too much difference. We're probably talking more like Microsoft-specific customizations or not. And then obviously there's the discussion of Navi 5, which, I think we all expected would be sort of around the mark for this sort of product. So yeah, I know there's been a lot of news about sort of like, Microsoft's talking about Zen 6 and Navi 5, but realistically, these are things that we'd probably be expecting with the 2028 sort of time frame.
Yeah.
It's like you'd be expecting these generations to go down that path. What else I found very interesting are the graphics innovation section here that Microsoft has listed, which I'll be honest, I think AMD will need to do a fair bit of work to get their GPU technologies up to the level of the things that Microsoft are asking of them here.
Okay.
So I'll read you some of these. We've got next-gen DirectX ray tracing, dynamic global illumination, micro-polygon rendering optimizations, ML-based super resolution, and extensibility model for fast iteration and innovation. Now, I would say that obviously we don't have micro-polygon rendering optimizations yet at this point. That sounds like something that would be used for like Unreal Engine 5 Nanite or something like that, like accelerating that. But next-gen DirectX ray tracing, AMD hasn't really proven that they've got the performance yet for high-end ray tracing, and ML-based super resolution is also a technology that they currently don't have. So there's a lot of things they've got to work on there.
Well, yeah, they've got 5 years and multiple generations to do it, so it's not impossible, but yeah, they've got their work cut out for them.
Yeah, they certainly do. It's kind of funny seeing those things in there being like, NVIDIA's obviously got this ML-based super resolution thing pretty much down pat at this point. Like they've optimized that to quite a significant degree at this point. It's running great. And Microsoft's like, yeah, we want that in our next generation console. And now AMD's probably finally got to pull the finger out and maybe improve this sort of thing, because I don't know about you, but I've been disappointed with the level of progress that we've seen from a technology like FSR2 since it came out. Like it's been out now for over a year and it really hasn't changed all that much. It's still very much the same sort of technology that it was, and it seems like AMD's mostly focusing on FSR3 at this point.
Well, maybe.
So, yeah,
it's on the box now.
It is
Hopefully,
on the box.
hopefully
Yeah.
we'll see it soon because they are advertising that RDNA 3 supports it. But I mean, well, as you say, technically it does support it. It just doesn't exist yet to support. So
We've tested a fair few games now at this point. Have you seen much in the way of like FSR improving since we've seen it? Like,
no, I mean, I personally think it's pretty unusable at 1080p. It's average at 1440p. The lower resolution you go, it becomes more clear that DLSS is superior. And then when you get to 4K, I think it's much more even. I'm not saying they're the same, but FSR2 quality at 4K looks really good. And obviously, so does DLSS quality. So less of a concern there, which is a bit of a shame because obviously that makes it more beneficial for those who are buying really high-end expensive GPUs, whereas if you're buying something like an RX 7600, you'd like a bit of performance boost. I don't know. I'd say upscaling's almost useless on those products. I know people will disagree and think that's a really poor take, but it just looks bad in my opinion at 1080p, like very blurry, very poor quality.
yeah, I would definitely agree with that, especially if we're talking FSR specifically. I think DLSS is also not super amazing if your final.
It's better, but I'm not sure I would use it at 1080p. 1440p, sure.
Yeah, 1440p is definitely usable. I think I've got my. Well, actually, by the time this video's come out, the DLSS 3.5 video will be out. In that video, I show the RTX 2060 running path tracing with at 1080p with the DLSS performance mode.
Yep.
Because DLSS 3.5 only works with the path tracing mode, so unfortunately, it's kind of restricted for people who are trying to play it on a 2060. Anyway, not only does that card run that mode awfully, but DLSS at 1080p with the performance mode is disgustingly bad.
Yes.
Like really, like you definitely wouldn't want to be playing with that technology enabled. And I guess
it's like quarter resolution.
Yeah, it's not really designed for like upscaling from 540p or whatever the actual render resolution is. It's more designed for people with 4K displays. You render it at 1080p and you upscale it from there. But it really doesn't look good. And yeah, so obviously FSR is even further behind in that regard. Like, I think I did some testing in it in Starfield, and oh my, like seriously, it's no good. So I think AMD's got, part of me is like, this is 2028. They've got 5 years to get this right. They've got plenty of time, but then also DLSS 1 was released about 5 years ago at this point, and they've been behind pretty much every step of the way. It took them like, how long was it till FSR 1 came out? It was like at least a few years, and then FSR 2 was then a couple of years after DLSS 2.
Yeah, I mean, it's definitely true that Nvidia is well ahead on that front. But when it comes to the Microsoft Xbox thing, what Microsoft wants and what they're going to get, two probably different things. And Nvidia is probably irrelevant in that picture anyway, because again, like if Microsoft wants that stuff, AMD can't deliver it, and they're like, well, we're going to go with Nvidia, then they've got to pay the price that Nvidia wants to charge to get that technology in consoles. And whether that's feasible or not is a totally different story. Look, maybe Nvidia wants to make it happen. I'm sure if they want to make it happen, they'll make it happen. Yeah. So it's sort of
cost.
Yeah, exactly. So it's not a situation where you're like, well, if AMD can't deliver by 2028, they're definitely going to go with Nvidia. It's like, probably not, would be my guess. I can't see Nvidia's technology ending up in the next gen consoles. Could be wrong, of course. I have no idea really, but just based on the margins and what we've seen to date, I don't think it's a possibility.
Yeah, I think we'll see it in the Switch too, but apart from that, I mean, that's not really the sort of performance
they already
level
do the
of console
Switch.
we're talking about.
It's sort of a totally different thing. So,
I think the issue here is like the way that gamers who are buying a PC will consider buying a GPU is very different to the way Microsoft will consider buying hardware for their consoles. Like a gamer is going to sit here and be saying, especially if you're buying like a high-end product, you'll be like, okay, well, I need to balance like the performance with the features. Like I'm going to be considering not just the frame rate that I'm getting, but DLSS, how's that factoring in? AV1 encoding, NVENC, the quality of the software, things like that. They're all going to be factoring that in. And you also have the opportunity to choose multiple different options. You can pair it with different CPUs. You can really do whatever you want. The whole benefit of the PC platform is doing that. Whereas Microsoft, they produce this list of things that they would like, but much more significant to that is the finances side, the economics of building a console, like how much it costs to produce. If they go with an Nvidia solution, potentially they're having to, especially if they want to keep x86 in the play, then that's two separate chips. They'll have to go with a separate CPU and separate GPU. Does it make the console much more expensive or harder to manufacture or less convenient? Maybe they can get Nvidia to make them an ARM solution again. They've got all those other considerations that we've talked about that don't necessarily make it as attractive. So I'm sure that some people would ideally like, DLSS in a next generation Xbox, but Microsoft's going to be much more concerned with how much does the APU cost than things like the super excellent quality of their super resolution technology.
Bit of a random one, but I was thinking while we were talking about price and stuff, if Microsoft, or say Nvidia rather, were to get into consoles, and we're talking about like PlayStation and Xbox, I wonder what that would actually do for PC gaming, because they could control essentially the market, the gaming market top down in terms of pricing. Because at the moment, you get the common argument that if the low end, like, your RTX 4060s and RX 7600s, they're pretty crap for the money. And a lot of people in the comments go, well, I'm just buying a console. Yeah, I'm not going to bother with the PC anymore. Yeah. And then if you get, if they did adopt Nvidia, Nvidia's like, well, we have to increase the price of consoles for, X, Y, and Z. And then we see console pricing go up, which is probably inevitable that it'll go up anyway. But if Nvidia gets involved, it'll probably go up more than it would have otherwise. And then, the sort of floor for consoles is around the $1,000. There's not really any incentive for them to make affordable PC graphics cards, so they can start at a higher price point. Because if you don't want those, then just go for a console. I'm not saying that'll happen. I'm just saying, like, it gives them much more control over the market than they currently have. Of course, there's still AMD and Intel who can produce those products, but they're relevant on a much smaller scale. So,
yeah, and I think on top of that, like, AMD benefits significantly from game developers effectively being forced to optimize their games for RDNA architectures, because the vast majority of games are released on PlayStation and Xbox, which use RDNA 2. So in some ways, AMD can save a little bit in terms of like developer outreach and things by being the default choice for the consoles. They're sort of like, well, you guys now you got to make it work. So then they can get that benefit for PC, which kind of does benefit for them from they don't have a ton of PC market share.
It cannot be overstated enough how much that tie-in benefits AMD. The Radeon division would be in serious trouble if Nvidia took over consoles. Like, it'd almost be a
monopoly.
It'd be a death blow. It'd be so bad. Like, what we saw with Starfield would be reversed for basically every single game coming to PC. Like, the Radeon GPUs would be nowhere. GeForce GPUs would be, it'd be so bad. Like, it'd be so bad, and AMD knows how bad it would be that they would not let it happen. And that's why Nvidia can't outbid them. It'd be worth AMD almost taking a loss on the console front to keep Radeon alive. It'd just be so bad for them if that happened.
I think to be clear here, we're talking about it being bad from a competition standpoint. Like, a Microsoft console with Nvidia GPU in it would probably be fine. PC GPUs technology-wise would be pretty good. Like, we would be getting good GPUs and good technology, but without competition, we would be getting them at terrible prices. And when you get this sort of effective monopoly, it then would make it extremely difficult for other players to come in and really shake things up. Like, we've seen the difficulties that Intel has had getting their GPUs optimized in a variety of games. They obviously don't have the market share of Nvidia, which incentivizes developers to optimize for Nvidia, and they don't have the console play of AMD, which incentivizes developers to optimize. And we've seen them struggle with major titles that have come out recently, things like Starfield. Now, the game does run now just fine, from what I understand, on Arc in Starfield, but at launch, there was sort of some driver issues there. And, that is the situation that we would be facing, but with two vendors instead of one, if we had Nvidia in the consoles. But again, you could easily make the argument that would improve the consoles, because Nvidia's GPU tech is quite impressive. So
more power efficient as well.
They've got better technology. They'd be able to hit these list of things that Microsoft wants to a better degree now and likely in the future. But then again, AMD has got 5 years to work on these things. So yeah, there's certainly a lot of things to play there. I think all of what we've been talking about is pure speculation because it is very, very likely, I would say certain, that this next generation console will be an AMD CPU and an AMD GPU in the one package. I think that's pretty much going to be set at this point. So yeah, everything's sort of theoretical, but it's sort of interesting to think about, at least from some sort of perspective, like what would Nvidia do with this sort of console. And we will see, I'm guessing, things like DLSS come to a Switch 2 type of console. So we'll be able to sort of see what they can do with that sort of package. Not that it's a fully performant console, but it should be reasonably impressive. One other thing I'm concerned about though is relying too heavily on technologies like frame generation for a future game console.
Yeah.
They don't really list things like frame generation here, but they're talking about AI and using these sorts of upscaling super resolution features.
I honestly, I think that kind of technology is very beneficial for consoles because consoles, the performance is so, as I said, they start off at technically a generation behind PCs, generally speaking, and you get 5 years down the track and the console hardware is so embarrassingly bad. You can basically build any new PC for as cheap as possible and it'll smoke a console. So, they start off being world beaters. Everyone thinks they're amazing and they do this and they do that and they're so fast. And yeah, you get sort of, what would you say, even midway through the life cycle of a console and they're pretty bad. The benefit of upscaling and frame generation can, help them maybe not age as poorly as what they have traditionally. But then on the PC front, we saw this coming with this upscaling, reliance on upscaling, and now we're getting like frame generation and stuff. And people are using that to say like path tracing is now possible in games like Cyberpunk and stuff. And opinions are going to vary. I'm not a big frame generation fan. I've tried using it a fair bit. I do not like it. Just don't like it at all. There's a couple of instances where it's not too bad. It works okay. That is heavily reliant on the starting frame rate though. But for anyone who's remotely sensitive to input and stuff, and even just the artifacting and stuff can be very annoying. So I'm not a fan of it. Also not a fan on the reliance of upscaling either. And it'd be good if upscaling was a thing you could enable to take performance to the next level, not sort of have things go backwards and get us to the level that's acceptable, if you know what I mean.
Yeah, exactly. Like you want to use upscaling, like a game, you'd want it to be like optimized for, let's say, 60 FPS or something like that. And then you use upscaling to take that to 90, 100.
Yeah, high refresh rate.
120
enable
FPS.
That,
but what we're mostly getting is optimization for like 30 FPS. And then all the presets have some sort of upscaling enabled, and you need to use that to sort of reach those high levels of performance. And that's something that I would be concerned about as a console gamer going into a next generation, is that there's all this talk with this generation about 30 FPS versus 60 FPS. And we're starting to finally see people criticize game developers for only releasing games at 30 FPS on these new consoles. I think back in the PS4 era, we didn't really see that. Most people were sort of content with 30 FPS. Now console gamers have gotten a taste of 60 FPS in a lot more titles, and game developers are trying to go backwards. Like they gave people the 60 FPS games, and now they're sort of going, yeah, but we can't give you Starfield unless we run it at 30 FPS and stuff.
Yeah.
And gamers are like, yeah, no thanks. So my concern would be that game developers target 30 FPS and then use frame generation to give you 60 FPS. The whole reason why 30 FPS is bad is not because, it's bad from a number of reasons.
It's bad because it sucks. It's very bad. The input's
it's
crap.
Very bad.
The motion's crap. But I know what you're getting at.
Yeah, it's like the key issue for me, like I'm not a super latency sensitive gamer, but once we're talking about 30 FPS, I'm a latency sensitive gamer.
Oh yeah, it's bad.
And if we're talking about generating frames, taking that from 30 to 60 FPS, that's not going to be a good experience and is not going to solve the issue with consoles running at 30 FPS. Like games like Red Dead Redemption 2, which I played on PS4, runs at 30 FPS. The game engine and the way the game is designed is very slow. Like all the inputs feel slow and sluggish. That's the way they want the game to be played. But then you throw on top of that, it running at 30 FPS, it feels like you're walking in treacle.
It's awful.
It's gross.
Yeah, it's awful.
And so if that's the sort of that's the experience you're getting, but it's now running at 60 FPS, that's not what I would have thought would be a super next generation experience for a next generation console. But you can sort of see the path that they're going, where they're certainly thinking about, at the very least, they're thinking about using something like frame generation to do that. Whereas in my opinion, they should be targeting 60 FPS and using frame generation for 120 FPS, because a lot of TVs now support 120 FPS or 120 hertz and things like that. So it would make sense that you can go from this sort of 60 FPS experience to, you're playing a single player game, the latency is still okay at 60 FPS with frame generation, and then you can utilize the high refresh rate capabilities of your TV to a bit better degree. Yeah, I think that's one to play out there. And, we've seen videos from people talking about this whole, is upscaling taking games in the wrong direction? I think the good news is there's only a few examples where I'd say that's the case. There are still other games that do run quite well without upscaling. Even, you brought up Cyberpunk with path tracing. Yeah, you need upscaling to run path tracing, but the game looks great without path tracing and can be run on fairly modest hardware while looking spectacular. So,
yeah, I think probably to take Cyberpunk to the next level, more so than path tracing, is high resolution textures. Like, have you noticed the textures, generally speaking, for a lot of the surfaces and details in Cyberpunk, it's probably the most dated thing in the game, in my opinion. Like, it absolutely needs much higher resolution textures. And yeah, I maintain that just using the standard ray tracing preset with textures that are twice the size, the game would look much better than it does with path tracing, and it would run at much higher frame rates. So textures are so important, and the textures in Cyberpunk are pretty flat because it's designed, the game works with the ultra ray tracing preset. It works on an 8 gigabyte graphics card. So very low resolution textures compared to what they could be.
Yeah, and of course it launched as well on last gen consoles.
That's right. Yep.
Had only 8 gigabytes of memory, so they had to consider that as well. I think the main issue I've seen, like I've been testing a bit of Cyberpunk at the moment, I think one of the issues that game has is the textures can look good some of the time, but the texture draw distance is not very good.
It's really bad. Just across a road as well. Like you can see it drop off just in that short distance.
And it affects ray tracing because I actually showed my DLSS 3.5 video one of these examples where you walk across the street towards like a window of like a shop front or something. And from a distance away, like a fair way away, it looks like just like a flat glass thing with natural looking reflections. Like it's almost like a mirror, but it's, like a glassy sort of mirror. The closer you get, you actually realize that glass is got this texture on it that's like smudges and it's dirty and grimy and has all these scratches and stuff. So when you're looking at it from a much closer distance, it's not actually supposed to be producing a mirror reflection. Like it's supposed to be this sort of like gross, dirty, you would get these diffuse reflections and things on it. And so, yeah, I think for that sort of next gen look, like where do we go from Cyberpunk path tracing? It's path tracing plus using 24 gigabytes of textures and things like that.
Well, at least having the option to use up to that anyway.
Yeah, exactly. Like you want to be able to step back and the ray tracing still look like the window has got some sort of texture applied and things like that. So again, I still think, we can criticize the textures. The Cyberpunk is still the best looking game on PC at the moment, in my opinion.
It's definitely up there.
Yeah, that's probably somewhere that things will have to go. And I think we've talked a bit about how at least in my opinion, games should be giving people that have 16 gig GPUs and 24 gig GPUs some sort of setting that they can utilize that takes that experience to the next level. Because still give people that 8 gigabyte option if it's possible and easy to integrate and things like that. But ultra texture packs and things would be quite nice in some of these titles.
Yes, certainly something to take advantage of PC. That's right. Not to derail the conversation, but talking about upscaling on PC, the other problem with upscaling when you're reviewing a graphics card, I think a lot of people like to treat DLSS as just this, this static feature. Like it has DLSS, so therefore that means something. But DLSS means something, in my opinion, quite different on an RTX 4090 than it does an RTX 4060. And that comes back to the resolution that we were talking about earlier. So typically if you have an RTX 4090, you're almost always going to be playing at 4K. I would say 1440p minimum. If you're playing at 1080p, you probably don't need DLSS anyway. But at 4K, there's certainly a lot of reasons to use DLSS on an RTX 4090. When you do so, the quality mode is probably going to be ample, and you're getting a really nice high quality image. So that's great. It's a strong feature, which we've said time and time again on the Harvard Unboxed channel. We're looking at high end parts, but then you go to an RTX 4060, and in my opinion, the DLSS feature, it doesn't come with the same weight. It's not as important as it is on an RTX 4090, and you'd think that's counterintuitive, like it'd be more important on a slower card. Like that card's going to need upscaling more. I think on an RTX 4060, I think it's fair to say you primarily, not necessarily because of the price of the card, but more just the resulting performance, you're going to be targeting more 1080p gaming, maybe up to 1440p with upscaling there, and that's where DLSS can be of benefit. But at 1080p, I don't know, I'm not a big fan of enabling DLSS, even the quality mode. I just think it does degrade, in most instances, the image a bit too much. I'm not sure if you agree with that, but I would avoid it where possible. And if you're going to be less reliant on using DLSS there, while it's still a beneficial feature, it's certainly something to consider. I just don't think you weight it as heavily as you would on an RTX, maybe 4070 Ti, 4080, 4090, for example.
Yeah, I agree with you on that one. I think what we're seeing from all these upscaling technologies is that the margin that you get when you have a high-end product with upscaling is a lot larger. Like there's a lot more performance you can gain because of benefits, like you're saying. You can run at a higher resolution. So for example, with the 4090, yeah, you can use DLSS quality, but if you're playing at 4K, DLSS performance isn't that bad. Like
Sure.
it's not the best way to play, but it's better, in my opinion, better looking than 1080p with DLSS quality. So when you're talking about, DLSS performance, generally speaking, can give you around double the performance, maybe a little under, depending on the title. That's significantly different than if you're playing 1080p and the only option is either no upscaling or DLSS quality, if you're talking about, image quality that's actually worth using.
Mm-hmm.
So DLSS quality may only be giving you, 20, 30% performance improvement. So yeah, the benefit that you can get just from a performance perspective with DLSS on a higher end product is a lot more than you can get on a lower tier product. And that applies to frame generation as well, because one of the issues we've talked about with frame generation is the lower the base frame rate is, the worse frame generation feels to use.
Mm-hmm.
So of course, frame generation doubles the frame rate on pretty much all GPUs. So the performance uplift is going to be roughly the same. But on a 4060 type product, maybe you only have the performance to run at 40, 60 FPS-ish natively, whereas on a 4090, you're running it at 100 FPS natively, in which case frame generation runs really quite well at a 100 FPS base frame rate. But then you're sort of looking at 40 FPS on a lower tier product, it's not nearly as good. And again, like artifacts get less as well when they're shown on screen for less time when you're running it at a high frame rate. So
that's true. Yeah, to clarify, we're not trying to minimize these technologies or anything like that. Like we're still saying they can be of benefit. They're typically less beneficial than they would be if you had bought a much more expensive product. And we're also saying, like we said earlier, like they're still better than FSR's almost useless at 1080p.
FSR. Don't use FSR at 1080p, please.
So we're not trying to diminish or minimize this Nvidia technology. We still think it's good. We just think I'm basically trying to explain from the perspective of someone who reviews GPUs. While Nvidia would love us to just universally apply DLSS, good, great technology, key feature of this product, the scale depends on the performance of the product and the resolution that you'll be likely using that product at. So I hope that makes sense.
Yeah, and I think that's a standard thing with high-end GPUs. It's like when you have a low-cost product, you need a low-cost product to get the basics right. And this is not just true with GPUs, it's true with any products, monitors in particular. Things like, it's all nice to have fancy RGB lighting, but if the panel quality is bad, then the whole product is bad. And with GPUs, the baseline thing that they need to get right is the performance of the card, the general non-upscaled baseline performance that the card is offering. That needs to be nailed down first, and then you can start thinking about additional things like ray tracing, like
Yeah.
DLSS. And so
Yes.
the higher tier product you get, the more you should be expecting those features to benefit you because they've already nailed the performance. And then, you're sort of looking at all those feature ads. Whereas with a low tier card, yeah, okay, DLSS may provide a benefit, but if they haven't nailed that performance, especially with like a 4060, you look at it, it's not that much faster than a 3060. They haven't really nailed the basics of the card. They've gone backwards in VRAM from 12 to 8 gigabytes. They haven't nailed the performance of that card. And you can say very similar things to the RX 7600. That card is very similar to the AMD's previous products. They haven't really nailed the baseline performance that card should be offering.
Yeah, no, I totally agree with that. Better products, better baseline is where you want to start, not having to rely on Band-Aid solutions to make them usable. You want them to be pretty good to begin with.
Yes. Let's go the other way. Let's talk about your $3,200 GPU.
No, that's a good buy, that one. Good value.
Now, in the video, I want to bring you up on something. You said that you can't afford a $4,000 GPU.
Can't do it.
Is that true?
Absolutely.
I'm looking behind you and I'm seeing quite a few things, quite a few,
this is a podcast.
Cards,
everyone's listening. They can't say anything. Tim's lying.
And you told me in the video that you can't afford this $3,200 GPU. What's going on there?
I don't know. You put me on the spot, Tim. I can't wriggle my way out of this one. I can't justify it. Let's go with that.
I think that's fair. Looks cool though.
Yeah. So a bit annoying about that because obviously when we do reviews, we like to try and be as accurate as possible, give you guys as much information as possible, at least relevant information. And one of the most important bits of information about a new product would probably be the price. So I asked Asus for the price and they didn't have that ready a week or two and they said they'd get back to me on it and I hadn't heard anything. And they actually gave me virtually no information about the product. In fact, I didn't get any information about the product until the day of the review, which I added a few bits and bobs to the script, but we were mostly there. Anyway, what's the MSRP, guys? What is the US MSRP for this GPU? I asked them that again on the Monday, which was the day before the review went live, and they finally replied and they said the MSRP is $4,000 US, which I was just like, oh my. I was kind of annoyed because I knew it would be bad. Like, Balin and I, Balin's the Harbour Unbox video editor, we were sort of guessing how much it would cost. I think Balin said $2,500, and I'm like, mate, there's no way. I'm guessing $3,000 is what this thing's going to cost. And he's like, oh, geez, that much. I'm like, yep. And they come and tell us it's $4,000. And I can't take this seriously anymore. Like, I already knew it was silly to begin with, and now it's just absurd. Anyway, the reviews go live and they list it on the ROG store for $3,200, so $3,200 US. And I'm like, well, is it $4,000 or not? And I thought maybe that was just a whole, like, it hasn't gone on sale yet. Anyway, contacted Asus the next day and they're like, oh, the price we gave you was the Australian price converted to US dollars. I'm like, what? Who does that? So they apologized. Yeah, they apologized and said that was their mistake, and they sort of misled me on that one. It is $3,200 as the MSRP.
Oh, it makes a big difference. It goes from being not great value to just screaming good value. You should be flooding to the stores to get that $3,200 GPU.
Absolutely, but the $4,000 US. Well, it'll be RRP. So technically, it is still $4,000 US, just here in Australia, which makes it like $6,800 or something in Australia. So pretty hilarious. But anyway, so I'm not sure what question you're asking, but that was what went wrong on the pricing front. So a bit annoying that I asked them for the US MSRP and they gave me some number that means nothing to anyone. But
hey, it doesn't. It's good to get the number right to know that it's actually $3,200, but it really doesn't change much about the product. Whether it's $800 more in that price tier makes no difference.
I said that to Bale and I said, thankfully this doesn't, because if it actually made the product reasonable value or, it changed the conclusion, or I'd have to delete the video because they gave me the wrong price, redo all of that work. So thankfully, $3,200, $4,000, Doesn't change anything I said in the video about it. Not that I really concluded whether or not you should or shouldn't buy it, because I basically said this kind of product isn't really a product whether I tell you whether or not you should buy it. I just let you know what it does, how it performs, all that kind of stuff. And if you're the kind of person that wants to spend that sort of money on a GPU, then you'll have all the information you need to go ahead and make that well-informed purchase.
Yeah, I mean, I don't think they'll be making too many of these products. These are the sorts of products that companies often make, where it's designed to just show off how good the company is. Like, you want to get people excited and hyped about Asus ROG products, or Asus ROG products, as they say. So you go and make this ridiculous overkill, super expensive, super cool looking product. And the goal of it isn't to actually sell it. The goal is to make it seem like you've got the best GPUs and the best products on the market, so that people who are buying a much more reasonable product, something might not even be a 4090, it might be an Asus 4070 or 4060, they go, oh, well, I saw that ROG Matrix and that looked pretty cool. So maybe an Asus 4060 is what I should be getting. I think that's a fairly common strategy that we see from these sort of Halo tier products. And people, because you see people in the comments saying, like, why does this product exist? Like, it's people who are probably interested in this could just get the same performance from the ROG Strix model, or theoretically other high tier 4090s. And if you're going to go with liquid cooling, I mean, a lot of people in that sort of price tier would just be doing their own, custom sort of put a water block on it, go crazy with that sort of thing. But yeah, it's really to sort of it's kind of like just a marketing product, really. That's the whole goal of it, at least in my opinion.
Well, yeah, I mean, it'd be really, and we'll never know, but it would be interesting to know how many of them they made, how much money it made them, all that sort of stuff. But
I reckon they might not even sell like 100 of them. Like, they'd probably make a few to get them out to reviewers and things. But as for actually selling them, probably a number in the hundreds at a guess.
Yeah, I've got no idea. We would have to wait till it goes on sale and speak to retailers. But anyway.
QH Freddy from our Discord has asked us, why did you review this AIB GPU in particular? Because we haven't been doing a lot of other AIB GPU reviews, at least like standalone reviews. You've been doing a bit of them in your reviews of certain GPUs, but why did you review this one?
I don't know if I have an interesting answer, really. I mean, the timeline sort of goes, we went to Computex, we visited the Asus booth, chatted with the employees there, and they said, oh, have you checked out the new ROG Matrix 4090 card? And like, yeah, we looked at it, it looks pretty cool. They're like, it's got liquid metal, it's got this, it's that. I'm like, yeah, it looks pretty awesome. And then they said to us, we'll get you a review sample when they come out. I said, sure, okay. And didn't think much more of it. Many months went by, and about a month later, about 3 weeks ago, they sent me an email saying, hey, you've got the ROG Matrix is on its way to you. You've got a sample incoming. I'm like, oh, okay. And they said the reviews can go up on the 19th. And that was sort of it. I'm like, all right, I'll have a look at this thing. If it looks interesting, I guess we'll do a video on it. I got the card. I'm like, this looks pretty cool. And I thought about it a bit. I'm like, do I want to cover this? Will it be worth the time investment? And I was like, well, we could pull it apart. We could rip the card right down. That could be fun. We could chuck, some thermal paste on there and see how much difference the liquid metal actually makes. We could maybe chuck on a cryo sheet. I've had in our calendar, which Tim will be aware of, cryo sheet testing on GPUs and CPUs and stuff for about 3 months. And I've not got to it. So I thought, hey, maybe this is a good excuse to do that testing as well and sort of tie all of that into the one video to make it a bit more interesting. And that's why I did it. There was no real other reason. I mean, if interesting products come our way, we'll generally look at them. It wouldn't have been something I would have requested, to be perfectly honest. But the video was quite popular. People enjoyed it. So it turned out to be a success. But there's really no reason why that one in particular, apart from the fact that it's just absurd. It's just crazy. Like, it's unlike anything else. But yeah, I think MSI maybe offered one of their liquid-cooled Supreme X models or whatever, and I ended up looking at just one of the air-cooled ones because I thought that would be, more relevant to our audience. So I looked at that instead, given the option. And I guess it's the same thing with this. Like, if Asus had said, we're releasing 2 new GPUs, one of them's like a light, tough gaming value 4090, it's like compact, but it performs well, and it's a bit cheaper, maybe it's an MSRP card, or we have this absolutely ridiculous ROG Matrix card, I would have picked the MSRP card. if I was given the option of like those two type of products, because one's significantly more relevant to our audience.
People like seeing cool stuff.
Yeah, it's like the Top Gear of GPUs, except
yeah, exactly.
Except there's no funny humor. I didn't crash anything. Before we move on from Asus stupid products, you triggered this one with me when you said, what did you say, Asus or something?
Oh, Asus versus Asus.
Yeah, so I'll tell a little bit of well, I think it's a bit of a funny story. I don't get out much, guys, so don't give me a hard time. But we did our first ever ad spot with Asus about a year or two ago now. Probably 2 years ago now. I don't remember the exact. It was a little while ago. Anyway, they wanted to advertise one of the products that we thought was good, and maybe it was a decent. It was a motherboard or something. And yep, sure, we're happy to advertise that. It's a good product. So they approached us. We made the ad, and they said the ad's great. The only problem is you've said Asus, because that's how I've always said Asus, and I thought that was correct. And they said you're mispronouncing the name. I'm like, okay, how do I pronounce the name? And then they sent me something that was Asus, and they said that's how you say it. So that the higher ups in the company had told my contact it's Asus, and I'm like, that's weird because I've got 3 different videos from your official YouTube channels, and they all say it different. Like they say it differently in the UK, they say it differently in America, and I think one might have been English speaking in Japan or something like that. Anyway, and I'm like, so what is it? Like, and then it turned out it wasn't Asus, it was Asus. But conveying that to me was way more difficult than you'd probably imagine it would. It was much back and forth. I did like 4 recordings before we actually got the A, like g'day, A, and then Sus. Because I think in the US, a lot of people say Asus.
Yeah.
It varies. Anyway, there's about 6 different ways to say it, but the correct pronunciation this comes from like, the higher ups at Taiwan. Like it's actually Asus. So it's one of the less optimal ways of saying it, I would have thought. But anyway, that's what it is. So we finally got there in the end, and we ran the ad, and I kept saying Asus for ages, and I've reprogrammed my brain, which isn't easy because it's not easy to program it initially. So reprogramming is even more difficult. But I now say Asus all the time.
Yes. So now I would have thought Asus, they say that the name Asus originates from Pegasus, as in the winged horse from mythology. Now, Pegasus, not Peg-Asus.
That's right.
Right? So I would have thought that Asus is closer to the word Pegasus than Asus. But
it's so much easier to say.
It is a lot easier to say. But anyway, that's just my thoughts. If it's based on Pegasus, then maybe Asus is not. Anyway, we'll move on because that's always frustrating. I'm still in the process of reprogramming my brain to say Asus every time. It is difficult.
It is. It's harder than it should be.
DLSS 3.5, Ray Reconstruction. Let's talk about this as well, because by the time this video goes out, we can officially talk about DLSS 3.5, and you, the viewer or listener listening to this, if you do have Cyberpunk, you will be able to check out DLSS 3.5 as well for yourself via the 2.0 update, which will be out at this point. So I've been spending the last week or so looking at DLSS 3.5, and to me at least, I think this technology is more compelling than frame generation. I think out of the gate, they've done a better job with it than frame generation. Obviously, it's supported on more RTX GPUs, but something I said in the video, I know, Steve, you actually haven't watched the video yet. I probably should have uploaded it for you.
I'm in the dark.
You're in the dark. So one of my issues with ray tracing has been the actual quality of ray tracing isn't that impressive a lot of the time. Like either game developers don't use enough ray tracing, so you get examples like F1 where it's like ray trace shadows you cannot tell the difference between. It's just totally pointless, tanks your performance.
I was going to say, you can tell your frame rate halves.
That's pretty much the only indication playing those games. And there are many examples of games that do that. And then there's another bunch of games where you've got like medium performance hit ray tracing, but then the quality isn't that impressive. Like you get these reflections that are really low resolution. They sparkle and shimmer and do all this. Like they just look gross, and there's a lot of obviously processing going on. And then you get your sort of like cyberpunk path tracing examples, which just brutally destroy your GPU. And yeah, I feel like part of the reason why at Hardware Unboxed we haven't been as keen on ray tracing is that we've tested it, we've turned it on, and we're like, I don't know, are those visuals worth the performance hit? Like, it's not the resolution of the screen space reflections is actually better than the resolution of the ray traced reflections, except now the ray traced reflections work in some other situations.
Mhm.
I feel like there's been too many examples of that. Whereas when you turn on ray reconstruction in Cyberpunk, the quality of the ray tracing is largely significantly improved. There are some areas where it does make it look worse. So obviously Nvidia has got some work to do there to sort of optimize some of these edge cases that you'll see in the video. But on the whole, things like reflection resolution is a lot higher. We don't get as much blur and ghosting when we're moving around because the denoising effect is a lot higher quality. Given that ray reconstruction has no performance hit, what we're effectively getting is better quality ray tracing at no additional cost to performance, which is what everyone has been asking for when it comes to ray tracing. Like, we want to turn on ray tracing, we can cop the performance hit if the visuals are worth it. And I feel like something like ray reconstruction is going to give us closer to that. And that's why I'm, at least personally, more excited about that sort of technology than something like frame generation, where the use case of I like frame generation. I'm not as much of a hater as you maybe. Maybe hater is a bit harsh, but there are some scenarios where frame generation is great, but there are a lot of scenarios where I wouldn't use it. Whereas ray reconstruction, I feel, should be enabled all the time. Yeah, that's sort of some of my thoughts if you didn't end up watching the video. The downside, though, is that with Cyberpunk, you can only use it with the path tracing mode for now. They are planning to add it into the standard ray tracing effects later, which will open it up to more users, because right now it's all well and good to say that ray reconstruction works on Turing RTX GPUs, but a 2080 Ti is not powerful enough to run path tracing at all. So they've kind of, goes both ways a little bit there. But yeah, I think once we start seeing something like this enabled with standard ray tracing effects, it's available across all RTX GPUs, then people will start, game developers will start being able to justify higher intensity ray tracing effects. We'll get the ray tracing ecosystem will get a lot better. So it's surprising that they haven't thought about this earlier than now, because getting this sort of I used some Battlefield 5 footage from in the DLSS ray reconstruction video, and oh my God, it runs so bad and looks so bad. Like, not only does it run terribly, but it looked terrible. And
yeah, it didn't get off to a great start.
Yeah, it didn't get off to a great start. And I feel like now we're sort of coming into the age where ray tracing is a bit more usable.
Oh, yeah.
And I think things like this sort of, justify a lot of the development that's gone into it. And I really hope that most ray tracing games will, even if they don't use ray reconstruction specifically, look significantly into their denoises and how they're reconstructing, the low ray count images, so that we can get much better quality. Because I think this really capped off, just to go on a tangent here, this really triggered me bad when I turned on ray tracing in Far Cry 6. This is when I was really like, okay, we're now like several years into ray tracing. We're getting these, they're not RTX optimized, they're sort of more just your general DXR. I think there was an AMD sponsored game.
That was AMD sponsored, yeah.
They've gone to the like bare minimum ray tracing, so it will run on AMD GPUs and things like that. And the quality of the reflections was so bad. Like, why even bother putting it in the game? I was just like, when I went playing and I'm like, oh my God, this is not what ray tracing was supposed to be. Like, it wasn't, you just enable these low resolution, terrible looking reflections. Yeah, I think things like that would have been improved with things like ray reconstruction. So hopefully it goes somewhere. We'll see it in more games. And I think NVIDIA's sort of, this to me feels more like a DLSS 2.0 to me, which was obviously a very good quality technology.
Yeah, it's also an absolute nightmare for testing as well. That's why sort of native's still king. It's so subjective. Like, if AMD goes down a similar path, which they no doubt will, you're going to end up with two different denoising technologies that go about it to two different degrees and get two different results. So then it becomes subjective as to which one's better. And even to analyze that, to work that out, like the amount of different scenes you'd have to look at in just one game and then maybe different resolutions and then different like quality presets and settings. Oh yeah, it's gonna be tough.
Yeah, it's going to make our lives a bit difficult there, but that's all part of the
Well,
fun of doing it, I guess.
yeah, there's basically no right though, because people can argue that this one looks better because of this, and then that one looks better because of that. Like you almost need to like you can't have something that's highly subjective in those sort of reviews. That's just why Apple to
Yes.
Apple comparisons, native testing is king, because you remove all of that noise, all of that nonsense, all of that BS from the equation, and you just get the actual result. Because anyone who prefers Nvidia is going to be like, this looks better, or if you prefer AMD, they're going to make a justification for why theirs is better. We're already seeing that. Like, we've come out and said DLSS is the superior upscaling technology, but then you get bashed left and right from people who prefer AMD because they'll make any kind of random justification for why FSR is better. And it's not that we care about that side of things so much, but it's more when you make a recommendation for a product, or these days we don't really give, at least in most instances, like buy this product because it's better. Like buy the Radeon RX 7800 XT because when it was launched, it was $100 US cheaper. So it's definitely better than RTX 4070. Like we'll lean on that value and say, for people who don't need, they don't mind that you don't get DLSS, which is a bit better, or you get the less mature ray tracing, so the ray tracing performance is not as good. If you're aware of all those factors and you still want to save the $100, then get a 700 XT. But if you're really focused on ray tracing, then probably going to want the GeForce GPU. So there's all those factors to consider as well. It's so far from black and white these days with graphics card recommendations that you really have to review the card like 3 or 4 different ways. Like there's not one conclusion anymore. And this just adds another layer to that.
I think the approach of splitting off features into separate content pieces does generally work quite well, because when you're talking about the graphics card itself, you want to know what are the things that are unique to that graphics card that make it different to not only the competition, but other products in that series. So you want to be looking at the raw performance of the card, generally speaking, power consumption, things like that, because that is what is unique to that card. Like the 7800 XT performs differently to an XTX. And then you can allow all your other videos and analysis and things to look into the features separately.
Mm-hmm.
So then people can sort of go, well, we know how this card performs baseline. We've got all the relevant information. We know its power consumption, the operating volumes and things like that. And then you can start applying which of the features on top of that are things that you're more interested in. Obviously, if you want to go into the GeForce ecosystem and you want a feature like DLSS, it's not just, well, I'm just going to buy GeForce now. It's what GeForce product do you want, which then is partly why you need to go about the sort of standard way of testing for reviews. So yeah, I feel like that way of going about things, and again, it can get very repetitive. Like you don't want to be going into every single review having to be like, okay, now we've tested the performance of these cards, the only thing that's actually different, and now we're going to have to spend 20 minutes recapping how DLSS is different, how video encoding is different, how driver features are different, and driver support and compatibility, because the reviews would be unwatchable. Like,
yeah, looking at those key features and dedicated content that takes an enormous amount of time and energy to create in their own right is the way to go about it for sure, because you just can't. They're not feasible for a ton of reasons. One, which you just talked about, it makes the review unwatchable because it's 40 minutes long or more. And then the amount of time that you'd have to invest into every review to like do that testing or whatever, or rehash that testing, it's just not worth it.
And it's repeating testing for no reason too, because if you test DLSS and you look at it across a variety of resolutions, it looks the same on every GPU. Like if you're playing 1440p quality settings, you don't need to then go and reanalyze 1440p quality settings later on a different GPU. It's the same.
Yeah, you want to be able to say that, generally speaking, DLSS is superior to FSR in terms of image quality, especially at lower resolutions. And I'm not going to dive in and justify and explain why that is. If you want more information, our opinion, go watch our dedicated content. Frame generation can be a useful technology. Typically speaking, it's only useful for those who play single player games. And ideally, the base frame rate has to be in a specific window. If you want to learn more about our opinion on that and all that information, we have a dedicated content piece on that. Like, you don't want to, because those videos you've done on those subjects are very long and very in depth. So it doesn't make sense to drag all that information up again.
I think my DLSS comparison video was like half an hour. I think DLSS 3 was like nearly 40 minutes. So if you had to put that on every video.
Yeah, now you got DLSS 3.5 Ray Reconstruction. So
Yeah, and it's just like it's just assessing these things as they go along. Like, yeah, okay, it's going to create a few more headaches for reviewers because now image quality is getting more different between different products. But that's just something that you look into over time. You sort of reevaluate how you're going about things over
mhm.
time. DLSS 3.5 is not going to make a big impact at the moment because it's not in very many games. Its impact is obviously only for ray traced scenarios and things like that. But obviously, if it becomes more relevant as time goes on, then you'd want to be focusing on that more in reviews. Like you'd
Yeah.
emphasize it more depending on how relevant the feature is. And then maybe AMD comes out with a competing feature, and then maybe you dial it back a little bit
Mhm.
because now the gap between Nvidia and AMD might have been massive, and now AMD's got a solution that's in a variety of games that is, it's taken that gap from 50% down to 10%. So then you don't need to emphasize it as much, but could still be a little better. So you need to still reference it. And yeah, that's just the sort of way that we would approach these things.
But obviously, Nvidia and AMD to a degree, they're always looking for technologies that give them an advantage.
Mhm.
And that's how ray tracing, hardware-based ray tracing, kind of got introduced to gaming and upscaling and all that sort of stuff. But yeah, look, I'm pretty, I don't know, I'm torn on features where Nvidia kind of have gamers and their customers sort of over a barrel on this one because, DLSS 4 now may only work on the next generation GPU. So if you guys want to get these new cool features, you've got to upgrade. And I guess they're well within their right to develop new technologies to incentivize people to upgrade.
I think it comes down to how, I don't know, like believable their
Yeah, yeah,
reasoning is
yeah.
for why it is a proprietary feature.
Mhm.
Like you kind of have to toe the line between, proprietary features generally aren't great,
Mhm.
but also you don't want to restrict people from gaining access to a good quality feature that requires some sort of proprietary hardware that's only found in their products.
Mhm.
So you kind of tossing up those two things, and I think at least with something like Ray Reconstruction, they have enabled it on all RTX GPUs because they probably weren't able to justify why it didn't work on just 40 series products. And Nvidia has said things like frame generation only works on our latest and greatest products because of our optical flow accelerator, and DLSS only works on Nvidia GPUs because we've got it to run on tensor cores. Now, people have sort of said and criticized that in the past, being like, well, we're not really sure how much of the tensor cores are used, and we're not really sure how necessary the optical flow accelerator is. At least there's some justification being made there. Whereas, yeah, if they sort of just made this feature and they're just like, well, this just runs on the shader cores, but it's driver locked to NVIDIA, that's not really a very good excuse, is it?
Yeah, until you can prove that, though, it's an argument that's not worth having.
Final topic for this podcast I want to take a look at is something that we've covered previously, as in we've reviewed Doe/Eve monitors previously.
We won't be doing that anymore.
Won't be doing that anymore, but also this article is very funny, very, very amusing to me as a reviewer. So basically, over on The Verge, Sean Hollister is their senior editor here, who a couple of weeks ago was putting to the test some of Doe/Eve's dodginess, let's say. So back to sort of give a recap of this, back when I tested the Eve Spectrum 4K, back when Eve Doe was known as Eve, I wasn't super convinced, I wasn't that trusting of them as a brand. So instead of accepting their offer for a review unit, I decided to buy the product myself, which I do sometimes for other products anyway. But I just thought in this specific example, I'm not super confident in this product and this company and their ability to send products. So I bought one, and there's a whole bunch of hassle there. They took a long time to send me the monitor. It cost a lot of money to send. It wasn't really, after all these delays and things, it kind of really reduced the value proposition. But at the end of the day, I did receive the product. I wasn't super happy with the customer experience, but I got it eventually. But a lot of other people have been complaining over the years about Doe/Eve products doing this sort of process where they would very early announce the product. So way before other competitors would get their sort of similar monitors out, they'd open up pre-orders for the product at a very attractive low price. And then over time, the closer they get to the launch, they would raise the price more and more. But typically what would happen is that, these products, they'd say, oh, this is coming out in 2021, and then it gets delayed to 2022, and then it gets delayed to 2023. And by the time that customers get it, all of their competitors have already produced products at a similar or lower price. And then there's all these refund issues where customers can't get their refunds from the company, or the products just are never shipped, or they're cancelled. You look at places like Reddit, you look at the feedback, and it's suspicious at the very least to see a lot of people saying, hey, I pre-ordered this product, I paid the super low price, I've never received it. You claim the product is in stock on your website, but why haven't you sent me the pre-order product? If it's in stock, why haven't I got the monitor? So anyway, Sean over at The Verge, he put that to the test by sort of asking customers of Eve whether or not they've received their refunds and stuff, because Doe came out and they said, hey, we're now refunding our customers. We're definitely refunding people. We're definitely shipping products. We're resolving all of these, negative, feedback that we're getting. We're improving our reputation. We want to improve. So we're creating this form. People can fill out a form and they'll get their refund. And so Sean at The Verge was like, all right, well, we'll see whether you actually do that then or not. And it turns out they didn't do it, which is very funny to me, because why on earth would a company say, we want to improve our reputation, we're making this form for people to fill out, and we're going to be refunding people? And why would they then expect that a tech journalist is not going to follow up on that to make sure that when people fill out the form that actually they do get their refunds? So basically, they've reached out to 42 current and former Doe customers representing nearly $50,000 in sales. And they say that most say they continue to be ghosted even after filling out the company's supposedly rapid response form. This is just obviously their reputation is really terrible at the moment, but why would you make a promise of refunding customers to a journalist to then not refund the customers? Like, that's just 101 basic level stuff of what you don't do.
Mm-hmm. Yeah,
so
I'm not sure what
very
they thought.
funny.
Yeah, I don't know what they're thinking there. Maybe they thought it would buy them time, or they wouldn't bother following up with it. I have no idea.
Yeah, it doesn't make a lot of sense. So yeah, I've sort of over the past year or two sort of definitely shied away from really talking about Doe products. And whenever I did, I was sort of like, hey, they're talking about pre-orders here, but in the past, other companies have definitely got their products out first. So don't take anything they say with any sort of grain of salt. But I think after this investigation, and there's some pretty damning things that are sort of said in this article about, some of the responses, some emails that were sent to customers, their feedback, refunds supposedly having been issued and then not being issued. And yeah, so basically they say out of 42 respondents, only 8 people told me they got their money back, but 4 of those were via forced credit card chargebacks. So effectively they were forced into it. So basically they had about 4 out of 42 people getting refunded through a more genuine traditional way. So it's really bad stuff. The company seems to be operating in a way that I'm not comfortable recommending or talking about. I think that effectively funding product development via a pre-order / early order system is not the way you should be doing business. That very much seems to be, at least in my opinion, reading this, the way that it appears their company operates. So they get these pre-orders in, that allows them to fund the development of products, and then they just try and get out of fulfilling those orders to those pre-order customers later and start selling the product at full price. That doesn't sit right with me. The best way of going about business is to get funding for your products first via some investment or loan or something like that, which allows you to produce the products, and then you can sell them later and recoup your initial loans and things like that. That's the way companies should be operating, not sort of preying on customers like Doe is doing. So very unimpressed with this situation. Very funny situation, not for the customers, obviously. They've really been screwed over here. But the way that Doe's handled this is very, very funny. And I think at this point, they've been fully exposed.
Yep, I'd say so.
All right, let's take a break. It's been a longer podcast episode than expected, and we'll come back and we'll chat about our boring lives. All right, we're back. And we've had some boring lives going on. Both of us, I don't think, have been doing too much, but I'm not letting you get out of this one, Steve. Friday night, last week, the Demons. Melbourne Demons.
I didn't watch the game. How did it go?
You can't tell me you didn't watch the game. That's
I've
BS.
I've not heard the result.
You haven't heard the result?
No.
I'm calling you just on your BS right there. You definitely watched it, and were there tears?
No, I wasn't shocked, to be honest. I thought to be fair to them, I think they generally played pretty well. I mean, obviously conversion was a problem again. Some of the misses were unlucky. Some of them were just, not great. But yeah, they probably deserved to win that one. I mean, they realistically probably should have won it by 6 goals. But
so just to give some context to people who have no idea what we're talking about Australian rules football, AFL, which is currently in the finals series. Steve supports the Melbourne Demons, who I guess the way our system works over here is there's 18 teams in the competition, and the top 8 ranked teams go through to the finals. And if you're in the top 4 ranked teams, you can lose your first final, but still progress to play a second final. So you effectively get a second chance if you're a top 4 team. Now, Melbourne, Steve's team, was a top 4 team, and they managed to lose both of their finals. So they got bundled out in straight sets.
By nothing as well.
Which is historically a very embarrassing thing and something that fans really hate to have happen. But the reason why Melbourne lost both of their games was that in both matches, they did not kick accurately. So they did not kick their goals accurately enough and ended up losing because the other team kicked their goals more accurately. And in this specific game on the weekend, they lost in the last minute of the game, which was... I kind of felt bad for you. I wasn't going for the opposition. I was going for Melbourne. So it was a little bit heartbreaking to see as well. But yes, I imagine that...
I wasn't stoked. So let's move on to the next topic.
The next topic was Port Adelaide lost in the same fashion, which was very funny to me as an Adelaide supporter.
Yes. So, they got a bit more smashed, to be fair. They
did get smashed.
They weren't... I mean, Melbourne were very in control of that game. Apart from the fact they lost it, but it was the same the week before. But yeah, no, other than yelling at my TV.
You didn't break her or anything? No throwing of remotes? Or...
no, thankfully, I can't afford to buy a new one, so I had to be restrained. I did a bit of work outside. We're in the process of moving 40 ton of gravel, so we're doing a bit of landscaping and stuff. I've got some cypress timber delivered. I'm going to make a few outdoor benches and things. So I'll be doing that next week.
Nice.
I'm hoping next week I can finish my monitor stand, but that's still a work in progress. But functionally, it is usable at the moment and is being used. We just built... So the video will be on the channel, I think maybe Saturday night. So in a couple of days from when we're filming this. My youngest daughter, Tessa, we've built her a computer, which for those of you watching the video can possibly see it in the background somewhere there. But anyway, we built her a computer. That was a bit of fun. Unfortunately, she got the influenza thing that I had, but she's sort of on the mend as well, but she's a bit behind me. So she was a bit sniffly or whatever and wasn't as talkative as she normally is. But her birthday's coming up in a few days. Promised her the new computer. Her old computer, which we show in the video, was starting to really fall apart. And she's got massively into Adobe Photoshop. She loves art and all that sort of stuff.
Nice.
So she's got into that big time. So the new computer runs that much better, and she's having a blast. So I'm about to go, once we wrap up here, I'm going to go take that in the house and set that up, which requires running cables through plaster and stuff. So that'll probably take me about an hour to get that all set up. But once it's set up, it's all neat and tidy and really cool.
Nice.
And yeah, other than that, just been enjoying the slightly better weather, getting, like I said, things done outside. And yeah, we'll probably cruise a bit over the next week with the channel, and then there'll be some big benchmarks and things happening the week after that.
Yeah, my garden, I was talking about some dirt patches in the previous...
Still got all your dirt?
Week. All the dirt's still there, but now the dirt has little green things in it. I believe they're called... green shoots or something, or little,
I don't know,
something like that. Don't know what they're called, but there's green things coming out of the dirt.
Okay,
and hopefully those will give me vegetables at some point in the future.
Yeah,
so
hopefully that's a positive sign.
Yes, the seeds seem to have worked. As a garden expert, that's all I can say is that I put water on the dirt, and the dirt is now got green things coming out of it. And yeah, hopefully in a few months we'll have some nice things growing out this way, which would be good.
Tim's hoping those green things are vegetables and not weeds.
Not weed. Well, I think they seem to be in the general vicinity of where I put the seeds. So fingers crossed that they're the actual things.
Okay.
No, it's been good. Springtime's been pretty good at the moment. Pretty
Yeah,
good in
it's a good
terms of
time.
weather and things. So things are starting to blossom, and my apricot tree is going off at the moment. So hopefully I'll have plenty of apricots in the next couple of weeks. So kind of hardware unboxed apricots for me just out this way. And
Nice.
it's nice. We'll have some more Cyberpunk stuff on the channel soon as well. Sort of the indoor stuff going on at the moment. Just testing some various different things with the Phantom Liberty update, and eventually I'll play Phantom Liberty through, so I'll be able to give you some of my impressions. I'll probably play it. I'm just interested to see what Phantom Liberty will be like playing it with path tracing enabled, DLSS 3.5. I'll probably enable frame generation. I'll chuck on all of the technologies that my 4090 supports, and we'll see what the end experience is like and how much better that is than turning all that stuff off, just playing with either normal ray tracing or the non ray trace mode, and see whether the experience is as enhanced as it should be when you're buying a $1,600 US GPU, or $3,200 if you get the Asus version.
Yep. Nah,
Um,
sounds good.
but yeah, I'm not a game reviewer. I don't play like 60 hours of games a week, so I'm not always like up to speed with the latest games. I've only played a little bit of Phantom Liberty. I think it's pretty fun. I played through all of the original Cyberpunk game and thought it was quite good. But yeah, I'll get to you'll probably hear from me in like December or January of next year. My thoughts on that. So everyone will have already played it. My thoughts will be well outdated, but eventually I'll let people know. So
Nice.
yeah, that's pretty much it for this one, unless you have any other things going on, but there's nothing much in our boring lives that happens. So
No, I'm looking forward to catching up on Monday next week for the Q&A series. That'll be good. But other than
that
that,
should be very good.
yeah.
That's pretty much it. So yeah, thanks everyone for listening to the podcast or watching it if you are on the Hardware Unboxed podcast YouTube channel. As always, we've got the audio feed or video feed, depending on what you want to watch or listen to. So yeah, you can head over to all the various platforms for that. And yeah, that's pretty much it for this one. Thanks everyone. We'll see you again same time next week.
See you guys.